Hello everyone and welcome to FN 1140 Finance. And today I'm looking at a particular type of problem that I've had some questions with, and this type of problem is when we have unknown replacement loan payments under the assumption of compound interest. I have an example problem here, and all these problems work exactly the same way. So let's take a look at the example problem and we'll go through it, and I'll explain the general concept as we move through the problem. Kramer borrowed $4,000 from George at an interest rate of 7% compounded semi-annually. Got a little bit of Seinfeld going on here. The loan is to be repaid in 3 payments. The first payment of $1,000 is due in 2 years after the date of the loan. The second and third payments are due 3 and 5 years respectively after the initial loan. Calculate the amounts of the second and third payments if the second payment is to be twice the size of the third payment. So what we have here is someone goes and borrows $4,000 right now, today. It's going to be calculated at an interest rate of 7% compounded semi-annually. Okay. There are going to be 3 payments to pay off this loan. So effectively, we have to pay off the loan. When we pay off the loan, we are going to pay $1,000 in 2 years' time. We're going to be paying an amount in 3 years' time and 5 years' time. Now, the trick is we don't know what those amounts are at 3 and 5 years, so we have to figure them out. So what we're going to do is we're going to set the amount as X. And you notice that the payment there, calculate the amounts of the second and third payments if the second payment is twice the size of the third payment. So what we have is that second payment comes in as an unknown amount, X, but it's twice the size of the last payment, the third payment. So it is really what we would consider in mathematics 2X, 2 times X, and the 5-year payment would be X. How do we show it? Well, we need to be able to rationalize it first. First of all, we need to know that the sum of all of the present values of the 3 payments, so that $1,000, the 2X amount, and the X amount, if we added up all those amounts, the present values of those amounts, it has to equal $4,000, which is the amount of the loan. Okay, that's the first thing that you need to understand, and all of these are set up the same way. We draw a timeline. Here's the timeline. This is year 0, the start of the loan. Year 2, where there's a $1,000 payment. Year 3, where there's a payment. And year 5, where there's a payment. Now, as it says, that the third year payment is twice as big as the 5th year payment. So we'll set it up as 2X and the 5-year payment as X. Twice as much. See how that works. Now, so effectively then, we have this, we have this, and we have this, and if we add up the present values of those 3 items, it has to match the beginning balance, which the beginning balance is $4,000, okay? So let's look into doing the present value calculations. We need to draw it back to present value. So first of all, let's take the $1,000. Let's bring it back and calculate the present value of $1,000 in 2 years' time. So there are 4 compounds. And the interest rate is 7%, compounded twice a year, so it's 3.5%. We need the calculate the periodic interest rate. So that's what needs to be calculated there. Then let's move down to the second payment. The second payment is twice as big as the 5-year payment. So 2X. And again, we have 3 years going on, so there's 6 compounds. And again, the interest rate, the periodic interest rate is 3.5%, 7% annual divided by 2 payments a year, so 2 compounds a year, sorry. So that would be 2.5. Then we have this 5th year amount. The 5th year amount is X. And again, over 5 years, that's 10 compounds. Periodic interest rate is 7 divided by 2, which is 3.5. Now, if we were to calculate this and this and this, add them all up, it will come to $4,000, right? So that's known. So we know we can calculate this PV1 because we have $1,000. We can calculate a value of X for there, and we can calculate a value of X for there, which is the second and third payment. So that has to equal $4,000. So the present value of 1 plus the present value of 2 plus the present value of 3 will equal $4,000. That's the basic concept. Now, let's look at putting some numbers to them. So the present value is really equal to, that's an equal to there, the present value formula. So we plug the numbers into present value, future value 1,000, the 1 plus the periodic interest rate to the number of compounds minus 4. That comes to $871.44. So in other words, today that $1,000 is worth $871.44. Now, here's the tricky ones. This is the x. So what we need to do is we need to do 2x, 1.035, again, same concept, to the minus 6, because there's 6 compounds. And that will give 1.627x. See how we can calculate the value of x there. We do exactly the same thing for the third payment. PV equals x, 1.035 to the minus 10, again, 10 compounds. And that comes to 0.07. X. So all we need to do then really is to add these up. So we take the 871, we take the 1.627, we take the 0.07. These are both values of x. So you can see that plus that equals 4,000. We solve here, we bring the 871 on the other side, which reduces that 4,000 to 3,128. That's 2, and we add 2 of these together, that's 2.3359x. 3128. We do a little bit of division here, and we can calculate the value of x to be 1339.33. So there's the value of x. So effectively, that would be the 5-year payment, and the 3-year payment would be 2x. So it's 2 times 13392, which would be $2,678. So effectively, when we add them all up, then we can calculate the value of x to be 1339.326. I hope if you followed that, you should be able to get a good understanding of how to resolve these types of problems. They're all set up exactly the same way. Thanks for watching. Let me know if you have any questions.